Project Hot Stuff by Ryan Barr, Lorena Barzabal, and Adam Wozniak. In this presentation, we're going to talk about the motivation of our project and the goals we wanted to approach, the equipment and materials, the setup, and the method we used. At the end, we will show a video of our device working. The motivation for this project came from the fact that it is very common for people to burn themselves when they eat or drink something that is too hot. We wanted to help blind people who cannot see that an object is too hot by creating a cup that makes a sound when the liquid inside reaches a desired temperature, since the only way for blind people to tell if a cup is too hot is by touching it. We chose a cup of coffee for our project because it is a very common hot drink.
The basic goal of this project was to create a device that regulated the temperature of a cup of coffee. If the temperature was below the given temperature, the hot plate would turn on, heating the cup of coffee up until it reached the temperature that was desired. If the temperature was too hot, a warning beep sounded so that the person using the cup of coffee did not touch it. The equipment we used to do this was a beaker of coffee, a hot plate, a DC power source, a mechanical relay, and the LabVIEW software. We also used a thermocouple and the voltage output. The hardware setup is as follows. The LabVIEW software used the thermocouple to send voltages to the filter. The thermocouple read the temperature of the coffee, and if it was below the given temperature, the power source powered the mechanical relay, which powered the hot plate.
For the coding, we put everything into a while loop so that the code would be continually updated as it ran. The thermocouple was connected to the DAC assistant, and that fed voltages to the signal filter. And this filtered the signal onto a waveform graph. We multiplied the signal by 1,000 to convert the voltages to degrees Celsius so that it'd be easier to determine what to figure out what our temperature was. We used a comparison and a desired temperature to connect it to a true-false loop in order to toggle whether we wanted the device to be on or off. The mechanical relay was connected to the DAC assistant, and when the temperature of the coffee was above 52 degrees, the false was shown and a warning beep was playing. And when the desired temperature is below 52 degrees, the true was shown and the mechanical relay gave power to the hot plate. This is the other page of coding. This is our numerical indicator that gave us our actual temperature. Here's the waveform graph that plotted our temperature change, and here was the dial we used to test our code. Here's a video of the footage of the device. You see the device turned on here with the little light. And that means that the hot plate is on and heating up the coffee. And now it's flickering on and off as it gets close to the temperature. And there you hear the beep in the background, the warning beep. We'd like to thank Jordan Horak for buying the coffee and Professor D for all of his assistance throughout the project.